Will you start? Organizers, are you ready? Could we start? Yes?
Yes.
Okay. Dear sirs, we are going to open session D. I am going to lead the session. My name is Tomasz Węgiel from Silesian University of Technology, and I am leading the session with co-chairman, with Mr. Dr. Adam Dering from Gdańsk Merito University. And because we are tired of excursion in Łódź, we decided to do that session without question, without discussion. We don't have time because we have many presentations, and it will be very difficult to organize a discussion. Perhaps after everything, we find some time for that. And what I would like to tell you more, that we have only 10 minutes for presentation, and at the 9th minute, I will be tapping the glass in the nautical manner. Why in the nautical manner? Because in the Polish language, city Łódź, it is boat, and it is a sailor's head. So it is like that. So please be punctual with the presentation. So Mr. Co-Chairman, once more, Dr. Adam Dering will announce first speaker. Please, Adam, it is Elise.
The first article to be presented will be by Dr. H.C. from the Warsaw University of Technology. Yes.
Dear Professor, dear guest, thank you for our visit to your university. The rector says that I can speak one of the three languages, Polish, Russian, and English, and I prefer the second one because it's my nationality language. I would like to present, chciałem zaprezentować założenia artykułu, który został opracowany w naszym zespole naukowym, który od ponad 5 lat bardzo intensywnie z sobą współpracuje. Mamy przedstawicieli różnych kierunków, różnych uniwersytetów. Uniwersytet Ekonomiczny w Katowicach, Politechnika Warszawska, Politechnika Częstochowska, Politechnika Warszawska to przede wszystkim jeden z organizatorów naszego spotkania. Mój zespół opracował założenia tego artykułu i mi przypadł obowiązku zaszczyt zaprezentowania najważniejszych jego założeń. Celem artykułu jest zidentyfikowanie oczekiwań młodego pokolenia w odniesieniu do usług transportowych oraz określenie znaczenia jednego z fundamentalnych trendów współczesnego zarządzania, jakim jest zarządzanie zwinne, agile'owe, adaptacyjne, czy też zarządzanie w czasie rzeczywistym. Przyszło mi studiować w czasach, które były okresem wielkiej transformacji, lat 90., kiedy Polak został papieżem. Przewodniczący Solidarności skoczył przez mur, a potem runął mur berliński i Związek Radziecki wycofał się z tej części Europy. Wydawało mi się, że nic bardziej fascynującego nie może się wydarzyć na świecie, a ja żyję w ekstremalnie ciekawych czasach. Musiałem zweryfikować to swoje podejście. Dzisiaj, pisząc o tym, pracując z młodzieżą od 30 lat, patrzę na ich oczekiwania i jestem zafascynowany, w jak ciekawych czasach oni dzisiaj żyją. Mi wystarczyło, że potrafiłem obsługiwać ten komputer i zostałem asystentem. Dzisiaj raczej pytam moich dzieci, co zrobić z tym komputerem. A technologie teleinformatyczne, które w latach 90. wkroczyły w każdą dziedzinę życia społecznego, politycznego, ekonomicznego, zrewolucjonizowały wszystko, w tym również metody skutecznego zarządzania organizacją. Był taki ekonomista radziecki Mikołaj Kondratiew, który twierdził, że to technologie wpływają na te zmiany. Określił znane w ekonomii długofalowe cykle koniunkturalne, ekonomiczne cykle koniunkturalne na lat 50, ale chyba nie przewidział, jak bardzo technologia w czasie będzie się zmieniać, jak będzie to geometryczny wzrost. Dzisiaj żyjemy w czasach kolejnej rewolucji. Można ją nazwać właśnie kolejnym trendem Kondratiewa, związanym ze sztuczną inteligencją. I to są te technologie, które determinują współczesne, agile'owe, zwinne metodyki zarządzania. I nasz artykuł stara się odpowiedzieć na pytania badawcze, jakie czynniki wpływają na postrzeganie jakości usług przez młode pokolenie, usług transportowych. To młode pokolenie, pokolenie Z, które w tej chwili wchodzi na rynek pracy, to pokolenie, które ma wysokie poczucie własnej wartości, ale patrzę też inaczej niż moje pokolenie na aspekt pracy. Kiedy pojechałem z synem na wakacje i poprosiłem go, żeby coś mi pomógł, to on mówi: tata, teraz jesteśmy na wakacjach, jak wrócimy, to ci pomogę, a dzisiaj daj mi święty spokój. Jednym z elementów tych współczesnych trendów w zarządzaniu jest work-life balance, czyli zrównoważony rozwój. To jest właśnie to, czego mojemu pokoleniu ciągle brakuje, a to młode pokolenie ma. I to jest jedno z tych oczekiwań, jeden z czynników, który kształtuje wyzwania dotyczące współczesnych rynków transportowych. Oprócz tego szybkość zmian, komunikacja z klientami, elastyczność oferty to bardzo częste czynniki, które zidentyfikowaliśmy na podstawie analizy literatury, które właśnie wpływają na to, w jaki sposób firmy powinny reagować na oczekiwania nowego, współczesnego pokolenia. Postawiliśmy hipotezy, jakoby szczególne znaczenie miały takie czynniki jak szybkość reagowania, nowoczesny wpływ nowych technologii, umiejętność komunikacji z klientami oraz zrównoważony rozwój, czy to, o czym przed chwileczką powiedziałem, czego egzemplifikacją stały się pytania badawcze naszego artykułu, a mianowicie jak ważna dla młodego pokolenia jest zdolność szybkiego adaptacyjnego reagowania na zmiany, w jaki sposób nowe technologie wpływają na jakość świadczonych usług, jak komunikować się z klientami w sposób mobilny za pomocą aplikacji, jakie to ma znaczenie dla wyboru usług transportowych i wreszcie czy działania przyjazne związane ze społeczną odpowiedzialnością biznesu mają dla nich jakieś znaczenie. Do tego badania zrobiliśmy badanie standardowe techniką KAGI, wykorzystaliśmy 476 respondentów, które to badania poddano analizie statystycznej. Na podstawie wyników badań sformułowano kluczowe wnioski, wśród których wysokie oczekiwania dotyczące elastyczności, szybkości reakcji oraz wykorzystania nowych technologii w zakresie cyfryzacji i komunikacji z klientem odegrało szczególną rolę. Na kolejnych slajdach są bardzo szczegółowe wyniki tych badań, które pominę w tej chwili i przejdę do zasadniczych wniosków, które wynikają z tej prezentacji. Na podstawie przeprowadzonych badań został stworzony model, którego sercem jest użytkownik usług transportowych, którego oczekiwania stanowią główny punkt odniesienia dla decyzji operacyjnych oraz strategicznych przedsiębiorstwa. Model ten teoretyczny, ale zawierający następujące główne założenia, a mianowicie integrację aspektów technologicznych, możliwości organizacyjnych oraz odpowiedzialności społeczno-środowiskowych. Oczekiwania młodego pokolenia są wysokie, co wskazuje na kluczowe znaczenie jakości oraz nowoczesności. Trudno dzisiaj wyobrazić sobie jakiegokolwiek młodego człowieka bez telefonu, bez mobilnej apki, który nie oczekiwałby również, aby informacje, które do niego spływają i które mają wpływ na jego decyzje, nie miały charakteru mobilnego. A więc cyfryzacja i komunikacja z klientem mają szczególne znaczenie, stanowią najważniejsze wymiary w ocenie jakości transportu, usług transportowych. Sprawność organizacyjna przedsiębiorstwa, która tutaj zostało sformułowane jako zdolność do szybkiego reagowania i dostosowania się do zmian. Ja bym dołożył do tego coś, co ex post wyłoniło się z tych badań, a mianowicie w mojej ocenie to jest przede wszystkim kultura organizacji, która decyduje o tym, w jaki sposób firma buduje swoją markę i pozytywny wizerunek. Tego nie ma w tym artykule, ale po analizie całości materiału dochodzę do wniosku za głosem jednego z ekspertów od strategii marki, że klienci dzisiaj nie kupują produktów czy usług. Klienci kupują marki, które są z nimi związane. I to jest właśnie to oczekiwanie młodego pokolenia, bo marka daje bezpieczeństwo, daje gwarancję, daje zaufanie. Dzięki marce kupują w Łodzi telefony, ubrania, Nike, iPhone i tak dalej. To marka jest tym kluczem decydującym o wyborze. Nie inaczej będzie również w usługach transportowych. Jakże to miło było ostatnio podróżować w Intercity, gdzie zarówno dress code, sposób obsługi, sposób ubioru klientów był na nieporównywalnie innym poziomie niż działo się to parę lat temu. No i elastyczność oferty zorientowanej na klienta. Klient zawsze był, jest i będzie. W latach 90. wymyślono Customer Relationship Management jako najistotniejszą koncepcję zarządzania. Tak jakby nagle ten klient pojawił się jak królik z kapelusza. On zawsze był. Ale aby go utrzymać, to nie jest tylko kwestia budowania relacji z nim, to nie jest tylko kwestia zaspokojenia jego aspiracji i potrzeb, ale to jest przede wszystkim efekt ekonomiczny, który on ma dać, bo klient daje efekt ekonomiczny, a relacja jest tylko narzędziem, sposobem, środkiem do tego, aby ten efekt ekonomiczny był. Dotyczy to każdej firmy, małej, dużej, wielkiej, każdej. Podsumowując już moje wystąpienie, należy podkreślić i położyć szczególny nacisk na identyfikację możliwości wykorzystania nowoczesnych technologii teleinformatycznych. Niewątpliwie ważne stają się narzędzia wsparte komunikacją z klientem oraz inwestowanie w aplikacje mobilne, systemy śledzenia usług w czasie rzeczywistym oraz rozwiązywanie szybko problemów w czasie kontaktu z klientem. Na tym zakończę wystąpienie.
Thank you very much for very nice presentation. Discussion at the moment because we have plenty of presentations. So I would like to announce another speaker. It will be PhD student of Sofia University of Technology of Bulgaria. Please, it's your turn. I will ask you to be punctual in the 9 minutes of your presentation. I will read it in the class as I inform you. Okay.
So, dear ladies and gentlemen, it is a great honor for me to be here. My name is Ivan Polevsky, and on behalf of Professor Sladkowski from Technical University of Sofia and myself, I will present you our research about multi-objective optimization approach for trolley bus transportation line. So the aim of this study is to provide a methodology based on multi-objective optimization and multi-criteria analysis to select the optimal transport plan. And the methodology was applied to the trolleybus network of Sofia, Bulgaria, as an example for the methodology. The main hypothesis of this research is that multi-objective analysis and optimization can improve the trolleybus transport network and enhance the performance of the network. So, literature review was provided. The main findings are listed here, but most importantly, integration of multi-objective and multi-criteria analysis is still underdeveloped, underexplored, although individually the both methods are widely studied. Our research consists of 6 main steps. You can see them listed here. The first one is determination of variance schemes, then defining the criteria for evaluating those schemes, solving the criteria weights by applying a multi-criterial analysis, then multi-objective optimization to determine the optimal variance scheme. And finally, performing a verification by another optimization method. So as I mentioned before, the first step is determination of the variance schemes. There is certain assumptions for this study, and the main assumption is that no investments are done to improve the infrastructure or the fleet. So the variance schemes differ the variance schemes differ from one another by the number and the type of the routes they have. 6 criteria were defined during this study. The first one is average energy consumption. Energy consumption was considered the most important criteria for the literature review. Average mileage per peak hour of the vehicles, possible transfers to other routes, also the number of drivers needed to operate the system, expected average delay, and the coverage by the routes of the neighborhoods in the city. In order to solve the multi-objective optimization problem, Bestward's method is used to evaluate the criteria weights. Experts identify the most important and the least important criterion, and then the rest of the criteria are compared pairwise. To evaluate their weights, optimization is performed. So in order to solve the problem, for each criterion, linear objective functions are formed. You can see them here on the left side. And the constraints represent the assumption that no additional improvements are made to the fleet. So we need to keep the number of vehicles used below the total number of vehicles in the city, and also the passenger flow in each section to be below the capacity of this section for the current variance scheme. Compromise programming is performed to optimize the 4 variance schemes. In this method, the shortest distance to the ideal point is found, and of course the result has to be the closest one to the ideal point and as far as possible from the nadir point. Verification of the results is performed by another optimization method of the same type. It is a modified epsilon constraint method. The main objective of this method is a function identified as the most important criteria, and the rest of the objective functions are transformed to constraints. Of course, we keep the other constraints as well. As I mentioned, the methodology is demonstrated for the trolleybus network in Sofia. So the first task was to determine and analyze the passenger flows. You can see a map of the passenger flows in Sofia trolleybus system. Based on these results, 4 variant schemes were developed. Each of them varies in the number and the route, well, the number of routes and the routes themselves from the other variant schemes. You can see here the evaluations of the criteria weights. 8 experts evaluated the criteria. They have it is not written here, but this is the energy consumption. So energy consumption again appeared to be the most important criteria. In order to evaluate the reliability of and the consistency of the experts rankings, Spearman correlation coefficients were calculated, and as you can see, the average values are above 0.7, which means that they have agreed on most of the weights. These are the results from the optimization process. This table shows the allocation of each vehicle for each route. So this is the main result for the 4 variant schemes. And the optimization results determine that variant scheme number 2 achieves the best overall performance. The consistency between the optimization and the verification actually confirmed that variant scheme number 2, which in both rankings is on the first place, is most likely to be the optimal variant scheme. So in order to evaluate the robustness of the criteria weights, sensitivity analysis was performed. And it was the results show that the selected optimal solution remains stable for the different scenarios. The optimal all the results for the 4 different variant schemes were compared to the current performance parameters of the network. So you can see the optimal variant scheme number 2 actually improves both the annual mileage and the annual energy consumption of the network. The conclusions are that an integrated best-first method and compromise programming can be used to make optimizations of such network. Criteria were defined to assess the trolleybus transport plan. Energy consumption was identified as the most important criteria. The methodology was applied successfully to the Sofia trolleybus network. Optimal schemes the optimal scheme reduces the energy consumption and the mileage. And most importantly, this whole methodology is applicable to other trolleybus networks. And by slight modifications, it could also be applied to other networks at all, like tramways or bus networks. This research was supported by the Bulgarian National Fund, so I would like to express my gratitude for this support. And now, thank you for your attention. I would like to discuss your questions probably during the coffee pause.
Thank you very much for good presentation. And now I would like to inform you that the third speaker didn't contact with us. So we don't have also in internet. But I will officially ask the third speaker, Agun Riardi, is not here, yes? Okay, so in that case, you are getting some extra time. And Michał, are we able to invite the 4th speaker that is waiting including internet? It will be Dr. Stani Pene from USA University in Bulgaria. So please give him for us.
Mr. Penev, can you hear us?
Dr. Vladimir Penev.
Yes, can you hear me, please?
Yes, Doctor.
Oh, thank you.
Start.
Can you please change the presentation, or can I share my presentation?
I can show your presentation, but
Yes, this is a different presentation.
Not presentation. Not notice. Email presentation.
The presentation is spatial temporal clustering and hotspot identification. Yes, this is the one. Can I control this presentation? How can I change the slides, please?
I can change your slide, but you must say to
Okay.
take slide.
Okay, so I'm ready to present now. Okay, so thank you for having me. My name is Stanimir Penev from University of Ruse, and together with my colleagues, we made a research on the topic of spatial temporal clustering and hotspot identification of urban road traffic accidents in the evidence of Ruse, Bulgaria, for the time period of 2021 to 2025. Can you take the next slide, please? Yes, so the core hypothesis which we had with my colleagues was that road traffic accident risk is spatially structured. So it's not a random across the urban area. So research was needed to be conducted from maps to statistics, and also visual clusters must be quantified. And the practical aim was to allocate priority zones and to support the targeted safety measures. The urban road traffic accidents are not distributed evenly. They concentrate around conflict points and high exposure corridors. Most empirical hotspot studies focus on large metropolitan regions, and medium-sized Eastern European cities remain underrepresented. The town of Ruse, Bulgaria, provides a relevant case for testing an interpretable GIS-based framework for road safety prioritization. Can you change the slide, please? The aim of the study was to identify spatial clustering patterns of road traffic accidents and quantify spatial concentration of accident risk in the studied area. So four main analyses were conducted. The first one was construct a grid-based aggregation of the data, which we transformed point features, point data, into comparable spatial units. These spatial units had surface measurements and a magnitude that says whether this small region holds traffic accidents and how many accidents it holds. And this grid-based aggregation was used to do the second analysis which we conducted, and that was the cumulative concentration index, which quantifies spatial inequality. After that, we made an average nearest neighbor analysis, which tests the global departure from randomness, which will further prove our theory. And the last analysis which we conducted was a hotspot analysis, which localizes and further confirmed our results, localizes the statistically significant hotspots. The study area was the urban area of Ruse, Bulgaria. The period of the traffic accidents were from 2021 until 2025. 1,690 road traffic accidents were included in this study, which included 381 injury-related and 12 fatal cases related. Can you change the next slide, please? So on this slide, you can see all of the data that we made analysis to. represented on the picture. The official data that was used for this study was taken from the official road traffic accidents record from regional directorate of the Ministry of Interior from Russia. Two sources more were used to further confirm this data and to fill in the blanks from the initial data. The second source was a public register, which was from a geo portal from the Ministry of Interior for the whole country, and another source which was conducted from a high school student who collected all of the traffic accidents data and put them on in a spatial platform, and he named this project Cherna Pista, which translated to Black Roads. So the boundary of the road network and was taken, and for the region of the city was taken from the OpenStreetMaps, and it was projected in the projected coordinate system WGS 84 UTM zone 35 north, which what we concluded was the best projected coordinate system to be used for such planar analysis over maps. So the reference study, which was for the area that was used, was 127.1 square kilometers. Next slide, please. The analysis workflow was, of course, a collection of the data. As we mentioned, it was a multi-source, which has one main source, and the other two was to fill in the blanks. The second stage was harmonization of all of the data. So the raw data needed to be harmonized. We fixed the attributes, and we input the right projected coordinate systems. So next step was the spatial filtering. We needed to clip all of the excess data which was outside of the boundaries of the studied area. So clipping tools and other similar tools were used for this process, and a quality control of the data. So all of the duplicates of the traffic accident records, all of the outlier road network logics was fixed. Again, continued with the first analysis, which was the aggregated analysis, which is the grid-based one. We created a fishnet, and we used the tool for spatial join to attribute to further attribute the data. And in the end, we started with the statistics analysis, which I explained earlier. So next slide, please. So these is on the slide. It's seen the regular grid plus spatial join analysis, the grid-based one. So a regular grid was generated over the study area and clipped to the city boundary. Each grid cell receives a count of road traffic accidents which fall inside. This transformed point events into comparable aerial units, and the grid layer became the basis for a cumulative concentration and hotspot analysis. Next slide, please. So this is the result from the cumulative concentration analysis. So the accidents are highly concentrated in small number of cells. This is the main conclusion out of this analysis. The severity gradient is clear. The injury and fatal cases are even more spatially concentrated. All 12 fatal cases fall within the top 1% of the ranked grid cells. This should be interpreted cautiously, of course, because the small number of fatal events, the number of fatal events is very small, so it is more likely to fall within the top 1% when it's such a small number. Next slide, please. The second analysis which we conducted was the average nearest neighbor. So the purpose was the test whether the global road traffic accident point pattern is clustered, random, or dispersed. So it compares observed nearest neighbor distance with expected distance under complete spatial randomness. This is the formula that was used. So we the nearest neighbor index was calculated to be below 1. So it means that it's highly clustered. So the observed is the observed average distance to the nearest neighbor between the points of the traffic accidents, and it is related to the expected, which denoted the expected average distance under the theoretical random Poisson distribution. So the observed distance was calculated to be 14.79 meters, and the expected distance was 137.12 distance. The nearest neighbor index was 0.107. Next slide, please. The next analysis was the hotspot analysis. A high count cell is not automatically a statistically significant hotspot. G evaluates whether high values are surrounded by other high values, and the output classifies cells by the confidence level of 90% until 99% hot or cold space spots. So with our research, we found out that there are no cold spots. We have neutral hotspots and hot spots only. G compares local sum of cell and its neighbors versus the global sum across the whole study area. And next slide, please, where the results of the hotspots for the studied area are shown. So you can see on the slide that the results over the grid network, there is the hotspots regions. So the strongest statistically significant hotspots are concentrated in the central urban area. A secondary linear hotspot pattern extends eastward along the major transport corridors, where is the connection with Bulgaria and Romania over the Danube bridge. And the third region is westward, where is a small cluster that appeared in the western industrial area of the town. So safety measures should be prioritized in spatially coherent high-risk zones that are shown on the slide. Next slide, please. These are the all of the analyses shown in this table. So the combined conclusion of the road traffic accident occurrence in Ruse are structurally concentrated rather than spatially random, which was actually our theory, and it was proven by the fourth analysis. Next slide, please. The practical implications of the urban road safety. To prioritize inspections and safety audits in statistically significant hotspots. So that's why these hotspot analyses were created. The target central area intersections and main corridors were exposure and conflict points and are concentrated. There is a structural risk. The use of the grid layer is operational. And we need to avoid city-wide generic interventions when risk is spatially concentrated. Next slide, please. So road traffic accidents, in conclusion, road traffic accidents in the study area show strong spatial concentration and statistically significant clustering. The concentration patterns become stronger with accident severity. The average nearest neighbor analysis confirms a major departure from complete spatial randomness. The hotspot localizes the main high-risk zones, and the proposed GIS framework, which was the whole process, the whole model that we represented now, is transferable, interpretable, and useful for medium-sized cities. So the end result is that we created from raw data records to spatial priorities shown on the map, and this can be input into other similar sized areas of study. Next slide, please. Thank you for your attention. And this research has been supported by this national program. Thank you very much.
Thank you very much. The next article will be presented online by Professor Aseno from the University of Rus in Bulgaria. Online? Yeah. Oh, please. No.
That's your presentation?
Yes, yes. Thank you. Dear colleague, I will present you first our team, Professor Elizara Pechova and Mia Senosun, who are here. Next is Ivan Georgiev, Associate Professor from Russian University. Also, young PhD, Svetoslav Babanov, and Maya Markova, and also one Associate Professor, Vyaka Rompova from Transport Faculty. And Ivan Georgiev and Maya Markova from Mathematical Department. Here, impact of transport activity on the dynamics of urban air pollution. On the picture, we can see the structure, transport activity, nitrogen dioxide, also atmospheric pollutions, PM 2.5, PM 2.10, also ozone, urban air quality, and short-term forecasting operational discussion. Practical value, adaptive traffic management, early awareness and assessment of short-term urban mobility measures. This information we collect from one system for 1 year for 2025. Next slide is from model selection to a forecasting protocol. Limitation of existing approach to a specific model class is often assumed to be superior. Comparisons are limited or namely in sample, and different pollutions are treated too uniformly. Operational application is not always demonstrated. Research objective is to develop and empirically validate a structured forecasting protocol for a short-term production of these four parameters. Working hypothesis, there is no universal best model. The appropriate specification depends on the statistical structure of the series. Data set and forecasting design, 200 weekly observation. The last 10 are held out for out-of-sample evaluation. For PM 2.5 fine particles, for PM2 coarse particles, nitrogen dioxide traffic indicators, and ozone secondary pollution. Data preparing, weekly aggregation, high frequency noise reduction, variance stabilization, and retaining transport driven changes. Validation logic, training samples, first 190 observation, test horizon, and last 10 observation, rolling on step ahead procedure, metric and RMSE, MEP and SME. Conceptual scheme of the study, transport factors and other pollutions, emissions, is for air pollutions, and links with forecasting setting. Iterative forecasting protocol with feedbacks, input data, after that processing, aggregation, and cleaning, statistical diagnostics, seasonally, model specification with benchmark model, MIF, MIN, ARIMA, SARIMA, WIRE, and CERCS, rolling forecasting procedure, forecast error, and you can see by the end result. Statistical diagnostic, ADF test, what is the stationary assessment and need for differencing, is if PSF lack identification and internal depends, and seasonality, periodic structure, and seasonal components. The diagnostic analysis determines the candidate models. This candidate's model, you can see 5 models. Logic is benchmark in univariate structure, seasonality, multivariable dependencies, and selective dynamic effects. This solid step ahead evaluation. Also information for this. Ranking. And here, SARIMA is for PM2.5 and PM10, various and CRX for nitro dioxide, and for non-dominate models. This is the result here. Conclusion, there is no universal dominant model for all pollutions. SARIMA is most suitable for PM2.5 and PM10 due to seasonality and persistency, whereas SRX perform better for nitrous dioxide and highlight the transport-related signal, and the proposed protocol is transparent, reproducible, and applicable on early awareness systems. Thank you for your attention.
Thank you very much for a very interesting presentation. And now will be another speaker online. I don't know if you are ready now to be invited. Yes. So, Professor, we are waiting for you. Could you hear us?
Yes, thank
Yes,
you.
okay. So, Professor Igor Karan from Ukraine, and we are giving you floor. Please, it's your turn.
Yes, thank you very much. But my name is Miroslav Liskevich. I'm professor too, and from Ukraine. And both of us, we presented our result of our research provided in Ukraine together with Dnipro Polytechnic and Lviv Nature Agrarian University. And dear Mr. Chairman, dear colleagues, thank you for the opportunity to take part in this conference. And I would like to introduce you in the result first, I think, result of our research. Next slide, please. Parking trucks can become a serious safety problem when the drivers does not have timely information about where there are free spaces. Then the driver must decide to continue driving tiredly in search of free parking spaces, or to park in violation of the rules, for example, on the shoulder of exits of the highway. Both situations pose a serious threat to safety. Next slide, please. If you take a look at this example, you can see that even in Poland, the network is equipped to parking lots is not very dense. I must say, in Eastern Europe, this picture is even more critical. Next slide, please. The problem is further become more serious by the fact that the intensity of free parking spaces changed over time. That is too uneven. Also, information about free parking spaces is also unreliable. Next slide. How its problem is currently being solved in practice. First direction, there are information services that inform drivers about free parking spaces in advance. However, by the time the drivers get to this place, it might already be occupied. Otherwise, the driver faces the unpleasant situation of violating the rules of 561 of European Union. Next slide, please. Second way, developments in the field of intelligent parking, as well as proposed approach to solving the problem based on artificial intelligence that do not provide a clear vision of the transition processes of implementing the latest violation. Next slide, please. The development of parking lot network on highways, in particular along the transport corridors of Europe, is carried out by the regularity method. The density of parking lots on the highway and the capacity depend on the intercity and composition of the traffic flow, the share of trucks in the flow. In particular, in the Eastern Europe, according to the revised rules of the European Transport Network, Europe Union member states must ensure the development of certified security parking lots every 100 kilometers on the core network by December of 1240. Next slide, please. The purpose of our study was to identify the nature of the influence of traffic flow parameters on the highway on degree of filling shortage of parking spaces in truck parking lots, as well as level of information support and the nature of decision made by drivers. 3 tasks were completed in order to get this purpose. Next slide, please. The basis of our approach to solving the problem was the assumption that the required number of parking spaces has a non-linear dependence on the intensity of traffic on the highway, where truck drivers are looking for an opportunity to park for intershift rest. That is why we used simulation modeling of parking process. This parking process was modeled using 2-dimensional modified cellular automation with bidirectional vehicle movement. The special of this methodology and kind of modification is present on this slide. Next slide, please. Here's a graphic interpretation of the simulation model. The next problem was the following problem, excuse me, was formulated and solved in the work. A highway was considered, which consists of at minimum 4 lines, 2 in opposite directions. The lines are divided by the double horizontal marking of type 1.3 according to the rules of the roads. In each direction, there is a possibility of 4 vehicles to overtake. Exit to parking lots on both sides of the roads is possible, both in the forward and reverse direction of the highway. Exit from each parking lots to the highway is also allowed from both sides. The intercity of vehicles exit from parking lots is equal about 5% of parking needs during the peak period. Next slide, please. The simulation results of each step were evaluated by next indicators. First, the level of parking occupancy is estimated by the occupancy rate. Second, the minimum level of satisfaction of driver needs in free parking spaces for rest. If the driver does not have information about free parking spaces, but his allowed driving time is T minimum, then he must take sure that he inequally is satisfied. Next slide, please. Cases of searching for a parking space depending on the available information about the occupancy of the nearest parking lots. So next slide, please. A modified simulation algorithm and a computer program for it have been developed. Next slide, please. Next slide. Thank you. The simulation was performed under variable initial conditions. The total intensity of the traffic flow in the forward and reverse direction of the highway, as well as variable average dancing of the traffic flow. In the first group of experiments, the simulation was carried out in the presence of 3 parking lots on a section of highway by 120 kilometers along with the total capacity of 45 parking spaces. Next slide, please. In the second group of experiments, the total capacity of parking lots was increased by 60 by 33%. The obtained independence allow us to identify patterns in the functioning of the parking lot network and increase the accuracy of calculating the capacity. From the nature of the change in level of occupancy of parking lots during peak hours on the highway, the following nature of the dependence of the driver's satisfaction coefficient can be determined as you can see on the dependence on the graphics. This is due to the small number of drivers in the flow who needs a long rest at the low values of traffic flow intensity. When the intensity changed in the range of 15, 17 vehicles per hour, the capacity of parking lots increases rapidly due to the increase of the proportion of vehicles with such drivers. This is continues. This continues until the flow intensity reaches its maximum value, at which the parking lots are filled as quickly as possible, and an increase in flow intensity make it impossible for many drives to park. At average values of intensity, the flow density should also be taken into account when choosing a parking space. This can be
last minute. You have 1 minute.
Thank you. And last slide, please. Let me introduce the conclusion. First and main impossible is to increase the accuracy of calculation of park network of motorways. It is necessary to take into account European Union regulation and information of available of free parking space first, in order for drivers not to violate the rules of safe parking and to have the opportunity for short-term and long-term rest. It is necessary to improve the method of calculating parameters by modeling, for example, by cellular automatics. Thank you very much.
Thank you. Thank you very much. The next article will be presented by Maxim Uroczka, a student of the Krakow University of Technology. Please.
So, dear colleagues, today on the behalf of our teams, or our team, I'm thrilled to present our framework for modeling public transport networks using open source data. I'd like to start from agenda, where you can see the structure of our presentation. The first one is, of course, a project description, then the data we used, proposed approach, case study we conducted, and of course, conclusions and future development. And it's really important point of this presentation. Talking about the project, it's a research and development project with cooperation with DPK system, titled An Integrated Transportation Planning System for Metropolitan Public Transportation, with a focus on electromobility and flexible adaptation to rapidly changing conditions. And our cooperation is concentrated on the second part, flexible adaptation to rapidly changing conditions. I will describe this a bit later. And it's co-financed by the European Funds for a Modern Economy for years, you can see on the slide. So we had a problem. We needed a functional graph that will allow us to use a customizable algorithms and different source of data, maybe our data, maybe open source data, to conduct our future researches. And it had to consist, of course, a road network and public transportation network. And we decided to use open source data, of course, because it's free and widely used in the whole world. And talking about transportation and road network, what can we use? What can we use? Of course, an OpenStreetMap, one of the widely used open source data. And we can three main options to import the data: Planet, Overpass API, and OSM NX. Planet is the first one proposed by OpenStreetMap, and it's really nice, but we have a problem with it because you have to download all the database they have. and it's roughly 2,200 gigabytes, and it's inefficient, of course, for a one framework, because we need the broad network for a one city or agglomeration. The second one is Overpass API. You can just import the data from OpenStreetMap directly in JSON format, and it's really nice, it's really useful, but because of our framework was developed in Python, we used OSMNX library. It does everything that Overpass API, but also it creates already functional graph of road network of the decided of the city, and you can use it for the researches and flexible algorithms. Talking about public transportation, public transport, what can we use? Of course, general transit fee specification that is widely used in the whole world and was developed by Google. And it's basically a zip archive of CSV files. You have 7 base files that every archive should contain, and 15 optional files. But on the right side, you see the structure of GTFS file from a GZM area, Górnośląska Zagłębiowska Metropolia. It's the main city of Katowice. And you can see every square represents one file. And you can see green ones, and it's like an extension of a files. It's not optional files, in extension of optional files and main files. And it's provided by the DTM or Zarząd Transportu Miejskiego. Talking about proposed framework, it's a 3-step approach. At the first step, we process GTFS data, then we build a graph network using OpenStreetMap and integrates all the data together. Talking about GTFS processing, you can see a diagram that explains every step, but roughly we import data, initialize classes, of course, define collections where we can collect those objects. Then for every stop, we should find the nearest shape. Shape is just the line that defines the exact route, like a geographical, exactly. And why do we need it? Because we have to, in the next step, we will have to assess to every stop one node, or real node, of a road network. Here we can see how we do that. We just take every shape assigned to this stop and find the minimum distance between them. The next one is, of course, graph network. And on the right side of the slide, you can see the road network of the KZM. It's really enormous because you have 35,000 nodes, 80,000 edges, nearly 28,000 intersections. Total length of the roads is more than 13,000. With this average length and nearly 3 average number of trees per one node. Talking about the data integration, we had 0 step of the integration. We had to filter out the stops with no trips assigned, because it's really the problem of GTFS. Not every stop is managed by buses. So we had to do it like stop link to any trip. If no, we just discard it. If yes, we apply 2-step approach. We had to find the nearest edge to this stop and then the nearest node from this edge to this stop. It's because of geographical. It finds like a geographical distance, and we had some problems defining just from shape to stop to node. Then we save graph and of course export CSV files with stops and nodes. And we validated our framework on the PKM Katowice routes. They operate on 56 routes across the GZM, not only in Katowice. You will see it on the couple of slides. In the next slides, It managed 1,281 bus stops and 3,162 trips. And talking about its GTFS that published by ZFM, it's like a really huge database merged for every operator. Because, for example, in Krakow you have a one operator has its own files. In Katowice, no. So here you can see the result of applying our framework. Red dots shows the locations of stops from the GTFS, and blue ones shows locations of nodes assigned to them. And as you can see, mostly they are very close. That shows the quality of work of our approach. And here you can see the bus network model. As I've said, PKM operates not only in Katowice, but also, for example, in Zabrze, Ruda Śląska, and an airport. And every line has its own color, of course. Now talking about conclusions and future development. So we presented our framework, three-step framework of modeling the transport network with open source data. It was developed in Python, and the main goal was to have a fully functional graph that can be used for future development, for future researches. For example, for, as I've said, emergency rerouting of public transportations in case of some accidents, or maybe when some civil working will be there, and many other cases of use this graph. Thank you for your attention.
Thank you. The next article will be presented by Professor Grzegorz from Princeton University in Kosovo.
Thank you very much. Dear representative of Constitution, dear participant of the honor to be part of this conference. I am professor at University of Christian Department of Traffic and Transportation. I'm developing in this process. So first of all, I would like to use this case to invite you to consider to involve your department in your network of collaboration, because this have a significant impact for us for our future development. Advanced traffic control, fraud integration, and controllers or sensors is the topic of my presentation. Why we have focused in this topics is because in the most common view of urban zone of Pristina, we see this view with traffic congestion where the vehicles need to stop in intersection with controlled by traffic light, which have impact also in air pollution and other indicators of traffic. And this view is also consists in other during the day, other times during the day, but during the night we also have a stop of vehicles in red line at intersection controlled by traffic light without any vehicle in other direction, in opposite direction or in direction that have a conflict with direction, for example, in this slide. So the main goals of this presentation, this research is to develop and evaluate an integrated adaptive traffic system that will use the microcontrollers and sensors depending on real traffic data to control the traffic light of the intersection. For the purpose of the intersection, you can see that we have developed on realized a prototype based on this technology and devices. The specific objectives of this research have to do with data collection by automatic traffic control and camera used in this case. Then analyze it and indicates of traffic by using mathematical model, and then to develop and evaluate, I said, the prototypes and a system by using technology and controllers and sensors also, depending on real traffic data from which arm of the intersection, a way to improve the quality of the traffic operation at the intersection. The traffic data in our cases and in our research are collected by automatic traffic counters that can measure the number of vehicles and also can categorize of vehicles in different categories, including cars, truck, bicycle, and other category of vehicles in structure of the traffic. In other case, when we have used a simple camera, we have used also the YOLO algorithm to measure the volume of traffic at the intersection. Two of our students are involved in our research, and they realized traffic control by constructed the prototype based in smart techniques use. In the first one of the prototype, we have used the Arduino controller, microcontroller, and also two types of sensors, the sensors infrared and sensors ultrasonic to measure the queue of vehicles in the stop line of the intersection. The principal work of these prototypes constructed by the students is based in real traffic data of traffic from each arm of the intersection. And when the first vehicles it's in the stop line of the arms, the infrared sensors can measure and can send the information to controller that we have vehicles in this arm of the intersection. Then the priority in the traffic light, the green light will be on for this arm. Then in the next one, if any of sensors in any arms of this intersection can measure and can detect any presence of any vehicles, in the next step, the green light will be open for the next arm. But we have to limit the maximum time of the green time, because if we have a demand from all arms of the intersection, we have to limit the maximum time of the green light. This is the principal work of this prototype, involving technology and smart techniques by using microcontrollers and sensors. And results also prove that, just you can play the video, short video maybe in this diagram. So the result prove that we have more effective green time used in this intersection by using these devices and this technology. This research and these prototypes also have been a part of sustainable urban mobility plan of some city of Kosovo, and in the field of the component of the smart, we have proposed to be implemented this kind of solution. So I am happy to share that some of municipality of Kosovo have started to use this kind of prototype, because actually I said before that all intersections are controlled by traffic light in principal work of XVIII. Please, you can play the video. Also, in this case, we have used software to analyze some indicators of traffic, included here the traffic delay, stop line, traffic delay in stop line of the intersection. Well, all road networks of the city is included in the simulation, and also there are included some two intersections controlled by traffic light, where we are applying this kind of or research or proposed research. When we analyze some indicators of traffic in the case of the intersection controlled by traffic light, we have seen that some indicators of traffic are improved, and in general, the performance of traffic operation at the intersection is improved compared to traffic light controlled by fixed time of traffic light. As a conclusion, also I can mention that traffic delay at the intersection based on real data of traffic from each arm of intersection are improved. Also, the fuel consumption is improved in this intersection because we have reduced the red light at the intersection, and the vehicles have to wait more or less in the intersection. And this is also in line with sustainable urban mobility principles. So I think maybe the best solution for traffic management is to combine the support of political support with technology and integrate it also the responsible from institution and from the industry. Thank you very much for the attention.
Thank you very much. Very interesting presentation. And now I would like to invite another speaker. Our guest arrived from Israel. It is senior research, Victoria Guterman. And the second author of the presentation, Ms. Caroline Patton, also here. So please, it's your turn. We are giving you 10 minutes as usual.
I will make it short. Thank you, Mr. Chairman. So my name is Dr. Victoria Guterman. I am a senior researcher from the Transportation Research Institute of the Technion, Israeli Institute of Technology, and also a consultant for the Ministry of Transport. And this study was done in cooperation with my colleague, Dr. Caroline Matar, who is the owner of My Roads Engineers Company, and also a consultant for the Ministry of Transport. And the study was financed by the Ministry of Transport in Israel through the Transport Planning Administration. Right. This one?
No, the second one.
The second one.
Yeah.
Okay.
That's right.
Okay, thank you. So in light of the growing congestion on the main road network and the need to encourage a shift from private cars to public transportation, public transport development has become the official priority in the country in the past decades. It is also associated with the expected benefits for sustainable urban development. Currently, preferential lanes for public transport are established across the main road network of the country in the form of bus lanes or routes for an exclusive or priority run of buses during all or selected hours of the day. The ultimate form of such arrangement is known as bus rapid transit or BRT. Nowadays, a nationwide program termed Rapid to the City is implemented in the country, which includes planning and setting of hundreds of kilometers of public transport lanes in various cities. To attain the mobility and other benefits which are associated with public transport priority, driver compliance with such priority settings is needed. The national traffic signs regulations in the country demand to indicate side lanes using yellow marking with yellow diamonds on them. You can see it on the picture. In addition, we have guidelines for planning BRT, bus rapid transit lanes, and there we can see the addition of red color stripes marking on such lanes. However, such special coloring of public transport lanes is not included in the Vienna Convention for Road Signs and Signals. In local practice, the use of special red coloring of public transport lanes began more than a decade ago, since the introduction of a new BRT system in the north of the country. Obviously, it was intended to highlight the special arrangements and to strengthen driver compliance with the new settings. Over the years, special coloring was applied in additional cities. However, the manner of the use was different between the authorities. Furthermore, special coloring requires regular maintenance, and this means additional costs. As a result, we received different opinions in the professional community of the country, and the Ministry of Transport decided to conduct a study which should consolidate insights from the international experience on the topic, and also to include a field experiment to examine the effectiveness of such coloring. The first part of the study was a literature survey, and the literature survey focused on two types of documents. First, regulations and guidelines from different countries regarding the need of such special coloring and the form of its application, and empirical studies which measure the impacts of such coloring on driver behaviors. They found that guiding documents on the topic were published in a number of countries, including the United States, Canada, the United Kingdom, and some others. Special coloring is applied for decades in North America, Europe, Asia, Australia, and New Zealand, aiming to emphasize such special arrangements. Today, colored public transport lanes can be found in many cities. You can see the list. And we found the red color is the most common in this context due to an intuitive association with a prohibition or warning for drivers. However, in some cities, also other colors are applied, for example, green color in New Zealand and Scotland. In many sources, the main disadvantage of special coloring is indicated. It lies in high maintenance costs. And to reduce the costs, in some cities, special coloring is applied only for newly established public transport lanes, where later on the coloring is not renewed. In other countries, partial application of coloring is used, for example, at special entry and exit points, like you can see in the picture, and on selected sections. In Israel, the coloring is needed along the entire lane. However, the width of the coloring is more narrow than the width of the public transport lane. I can mention a study conducted in New York, which compared the effects of partial versus full coloring, and actually they did not find a significant difference in the effect. Observational studies on the topic concerning the impacts of special coloring of public transport lanes are not frequent in the international literature. We found a few studies which included field experiments and observations from several cities in the United States, Canada, and the United Kingdom. They typically reported on positive impacts of such coloring, which resulted in a lower use of special lanes by private cars, and as a result, in improvement of bus travel times, and also a lower need in police enforcement of such arrangements. But overall, in summary, a range of practices exists in the international literature, where some countries do apply special coloring, but others do not. And in general, it is considered as a complementary and not obligatory treatment. In the field experiment in this study, we aimed to examine whether the type of lane marking has a significant effect on driver behavior. The study was designed to compare driver behaviors under two types of pit lane marking conditions, before using yellow diamonds only, and after with the addition of red color stripes. Under both conditions, field observations were conducted using similar methods, for both for data collection and for the evaluation of behavior indicators. After long consultations with national and local authorities, the municipality of Jerusalem agreed to conduct the experiment. For that, one route was selected, which is an urban arterial with a dual carriageway layout. It has a right side public transport lane in one direction with an additional lane for general traffic. Along the road, two sides were selected for observations, one side on the road section and another side in the area approaching signalized intersection. At both sides, video cameras were installed to collect driver behaviors. It was done in each period for 2 days, along 5 hours of highest traffic volumes. Here you can see the view of the road under before and after conditions, meaning with yellow marking only and with the addition of red color stripes. The results show that concerning the hourly traffic volumes at the study sites, in the after conditions with the addition of red color stripes compared to the before. In the total traffic volume, actually no significant change was observed. It was a slight increase of about 2% only. On the general traffic lane, again, an increase was observed by 6 to 8%, but not significant. In contrast, on the public transport lane, a significant decrease was found by 17 to 27%. Concerning the rates of illegal vehicles that use the public transport lane, in the after conditions compared to the before, on the road section at site 1, only a slight decrease was observed and not significant. However, near the intersection at site 2, a significant decrease was found of 22% on average, and also the decrease was consistent and significant in both days and across most observation hours in the study. In summary, the study results show that the addition of red color marking to the public transport lanes improved drivers' compliance with such arrangement. We found in the intersection area a notable and significant reduction of 22% that was consistent across most observation hours. On the road section, only a slight decrease was observed. In addition, there was a consistent decrease in traffic volumes under the after conditions at both study sites, indicating actually a shift from using the bus lane to using a general traffic lane, and that means clearing the bus lane for bus traffic. Overall, the impacts were positive and supported the use of red color marking on bus priority lanes. And based on the study results, the continued use of red color marking on such public transport priority settings was suggested, with a focus on more problematic areas where driver compliance with traffic regulations is the most important. I thank you for your attention.
Thank you very much, Dr. Victoria. And because here is also Dr. Caroline, perhaps you would like to add something? Or no. Okay. So once more, thank you very much, and thank you very much that both authors arrived for us. It's a great pleasure, great honor for us. And now I would like to invite another speaker. It will be presentation online by Professor Lilia Savchenko. Could you hear us? Yes?
Yes.
Could you hear us? Okay, so it's your turn. Please, you can start. You have 10 minutes. Okay?
Да, но я не вижу. Да.
Excuse me, you have 10 minutes for your presentation.
Нет, я не вижу у себя презентации. Все, вижу. Первый слайд. Все, да. Окей. Уважаемые коллеги, члены оргкомитета, здравствуйте. Благодарю за возможность представить наше исследование. Тема доклада «Комплексная методика оценки риска потери груза при автомобильных грузовых перевозках, построенная на сочетании метода анализа иерархии теории нечетких множеств». Работа выполнена авторским коллективом Национального университета биоресурсов и природоиспользования Украины, город Киев. Второй слайд. Потеря груза – это частичная или полная утрата его количественных и качественных характеристик, физической целостности и коммерческой ценности. Это транспортный риск техногенного характера, который возникает на каждом этапе перевозки, при упаковке, при креплении, при погрузке, при выгрузке, в движении. Несмотря на широкий арсенал мер, специализированный подвижной состав, современные средства крепления и системы мониторинга, это уровень потерь остается от этих действий очень значительным. Главный тезис прост. Набор разрозненных фрагментарных мероприятий себя исчерпал. Необходим переход от точечных решений к системному управлению рисками на основе количественной оценки, моделирования и прогнозирования. Именно эту задачу решает предлагаемая методика. Третий слайд. Цель работы – разработать методику оценки рисков потери груза на основе обзора и систематизации основных факторов потерь и их количественной оценки. Для ее достижения мы поставили 3 задачи: систематизировать факторы и построить их номенклатуру для внутренней и внешней среды, выявить доминанты, ключевые факторы риска методом анализа иерархии и, наконец, рассчитать интегральный индекс риска R-интегральная. 4-й слайд. Методология. В основу положена логика и лингвистическое моделирование рисков. Мы используем 2 взаимодополняющих инструмента. Первый – это метод анализа иерархии, попарное сравнение критериев, который дает относительные весы, которые количественно отражают коллективные суждения экспертов и учитывает психологический аспект субъективной оценки. И второй момент – это теория нечетких множеств. Она формализирует качественные факторы, не имеющие прямого количественного выражения, и улавливает нелинейный, неявный характер и влияние их на риск. Синтез этих подходов позволяет представить экспертные знания в виде аналитического выражения полиноминального типа. Весы факторов нормируются так, что их сумма равна единице, а итоговый интегральный индекс риска вычисляется как взвешенная сумма произведений весов на уровне проявленных факторов. 5-й слайд. Внутренняя среда – это 7 факторов. Это упаковка, маркировка, погрузка, размещение в кузове, крепление, выгрузка и квалификация водителя. Доминантной группой закономерно оказывается крепление груза, поскольку именно оно гасит инерционные силы, действующие на груз в процессе движения. 6-й слайд. Внешняя среда – это 8 факторов: природно-климатические, политические воздействия, аварийность, криминальные действия, техническое состояние транспортного средства, состояние груза, сопроводительные документы и дорожное воздействие. Здесь доминантной выступает дорожное воздействие, то есть состояние покрытия дороги, геометрия дороги и информационное обеспечение. 7-й слайд. К оценке привлечены 10 экспертов, специалистов транспортной отрасли. Они работали с 15 факторами и сформировали 2 матрицы попарных сравнений. Согласованность матриц проверена по методу Саати. То есть это максимальное собственное значение около 8. Индекс согласованности порядка 0,024, отношение согласованности где-то 0,017. И поскольку отношение согласованности существенно меньше 0,1, матрицы признаны согласованными, а экспертные суждения непротиворечивыми. 8-й слайд. Весовые коэффициенты, весовые коэффициенты подтверждают качественный анализ исследования. Во внутренней среде с большим отрывом лидирует фактор F5, то есть это крепление груза, с весом около 0,224. Во внешней среде небольшой вес у фактора Z8, дорожное воздействие. Это эксплуатационные свойства дороги, где перемещается транспортное средство. По исследованию оно становится около 0,214. Таким образом, 2 доминанты выделяют объективно на основе количественных расчетов, а не экспертной интуиции. 9-й слайд. Для перевода качественных проявлений в числовую форму введена 6-уровневая шкала от S0 отсутствует со значением 0 до S5 критической со значением 5. Проявления факторов, выявленные в вопросе, систематизированы по степени проявления риска и по группам среды. Это распределение служит входной базой для метода анализа иерархии. Для доминирующих факторов крепления получается критический уровень 55, а дорожное воздействие это высокий уровень 50 S4. 10-й слайд. В результате проведенных исследований итоговый интегральный индекс риска составил 0,56, что соответствует уровню выше среднего. То есть внутренние факторы формируют 56% значения индекса. Наибольший вклад вносит крепление груза и дорожное воздействие. За ним следует квалификация водителя и размещение в кузове. Это означает, что управляющее воздействие нужно концентрировать в первую очередь именно на этих позициях. 11 слайд, пожалуйста. Подытожу. Первое. Разработан алгоритм, последовательность процессов качественно и количественно анализа риска для конкретного вида перевозок. Второе. Внутренняя доминанта, то есть крепление груза, что подчеркивает критическую роль технологической дисциплины и контроля средств крепления. Третье, внешняя доминанта, дорожное воздействие, то есть сохранность груза зависит от состояния инфраструктуры. И четвертое, ключевая доминанта, это значение индекса 0,56, имеет системный характер. Его нельзя снизить локальными решениями. Необходим комплекс технических, организационных и инфраструктурных мер. 12 слайд. Благодарю за внимание. Предложенная методика носит универсальный характер и может быть адаптирована под конкретный вид груза и маршрут. Спасибо за внимание.
Thank you. Next article will be presented Professor Andrej Gulic from Slovenia.
Thank you very much, Mr. Chairman and co-chairman. Let me first introduce very briefly myself. I am a researcher at the Urban Planning Institute of the Republic of Slovenia, which is the central public research institution in the field of urban and spatial planning in Slovenia, which conducts research and professional work on spatial development and planning, as well as on virtually all related sectoral aspects. One of these aspects is also the development of the transport system and infrastructure. And the title of my presentation is Transport Infrastructure and Spatial Development in Slovenia, which is based on the recently completed project, named the concept of the Spatial Plan of Slovenia. This project was commissioned by the Ministry of Environment and Spatial Planning and represents a fundamental expert basis for the preparation of the Spatial Plan of Slovenia. Within the time available, I will aim to present the content of the paper concisely. Please, next slide. Well, what is the main purpose of my presentation? The purpose of the concept of the Spatial Plan of Slovenia was the preparation of the state-of-the-art overview and coordinated proposal for the implementation of sectoral policy in spatial development, and also ensuring the rational and complementary use of the space at the level of Slovenia. The next purpose is also to align this expert basis with the relatively new spatial development strategy of Slovenia, and the last but not the least, also reaching agreement on development and protection objectives of the state while preserving spatial quality and resources. Please, next slide. The main two objectives of this expert basis are establishment of a coordinated national planning frameworks and the support for the spatial allocation of key development projects up to the 2050. Well, the content of the concepts have five main chapters: settlements, transport infrastructure, energy, landscape, and natural resources. Well, the main aim of my presentation is to concentrate on the content of these first two chapters, settlements and transport infrastructure. Please, next slide. Well, the concept of the Spatial Plan of Slovenia represents a set of coordinated professional baselines for the preparation of the Spatial Plan of Slovenia as a national planning document. The Spatial Plan of Slovenia in preparation represents the first comprehensive national spatial document since 1986, when the long-term so-called long-term plan of the Socialist Republic of Slovenia for the period from 1986 to 2000 was prepared. In this 40 years interim period, we have prepared two very important strategies. The first one was prepared in 2004 and the second one in 2023, and also numerous national special plans predominantly focused on the planning of transportation infrastructure. Please, next slide. Well, in these periods of 40 or 45 years in Slovenia, we built 630 kilometers of motorways and expressways. The first section of the motorway was built in 1972, and it was only 30 kilometers long, but it was the first one, not only in Slovenia, but the first one in the whole ex-Yugoslavia. At the same time, I mean, this rapid development of transport infrastructure primarily focused on the motorway network. I mean, together with other factors, for example, the economic development, structural changes, and so on, significantly increased the number of automobiles. And this increasement contributed to an increase in the long-distance travel and indirectly the changes in the settlement patterns, with a pronounced expansion of settlements in areas connected to the motorway network. And this led to a sharp increase of automobilization. Please, next slide. Well, the key challenges of transport development in Slovenia are listed here, I mean, on the slide. I will stress only some of them because of time shortage. One of the problem or one of the challenges, of course, imbalanced development of transport subsystems, despite numerous strategies, slow and costly railway modernization, also no competitive rail travel times compared to the road transport, and overburdened Ljubljana node. Ljubljana is the capital of Slovenia, and Ljubljana is also the intersections of corridors. And this causes a very huge special and environmental problems. Please, next slide. That's why the concept of the special plan of Slovenia proposed the concept of transport accessibility on 4 different levels: on international level, on national level, regional level, and the local level. Well, at an international level, it is so-called internationally connected Slovenia. And this concept is structured with 4 items. The main topic is to connect Ljubljana and other urban centers in Slovenia with the nearby very important metropolitan centers in Milan, in Italy, München, in Germany, also Vienna in Austria, Budapest in Hungary, and also Belgrade in the Republic of Serbia. Please, next slide. At the regional level, we named this concept 60-minute Slovenia. And this concept is ensuring accessibility for the population to the first level centers within 60 minutes via the road network, and the mutual interconnection of first level centers by rail within 60 minutes. It is, very ambitious aims, but our state is struggling with the modernization of the railway network and also building the new sections of the road transport network to somehow implement this aim. Please, the next slide. At the regional level, the concept is made 30-minute regions, and it means that railway lines and also motorways must be updated to make accessibility to the regional centers possible in the 30 minutes. Please, next slide. And the last level is the level of the local communities. And the main aim of this concept is to somehow ensure that the local urban areas are connected, I mean, with the different types of transportation within 15 minutes. Please, next slide. Well, this have a very, implementation of this concept has a very important impacts on the ensuring the development of the polycentrical system of Slovenia. That means that the whole development is not located only in the main urban centers, but also in the less important centers or in smaller centers. Please, next slide. And this concept also supports very much the network of the business zones, which are located in the northern points of our transportation network. Please, next slide. These are two maps showing on the left side the synthetic map of transport and transport infrastructure, and on the map on the right side, the protection, regeneration, and development of settlements. Please, next slide. So, what are the key messages of my presentation? The first message is that the development of transportation infrastructure is not neutral, but has very important special effects. That the extent of development also only on motorway development leads to suburbanization, and that the rail network is the key to sustainability mobility, and accessibility is a key instrument of spatial development. Thank you very much. I bring the next slide. Thank you very much for your attention. It was very hard to present the content of my paper in 10 minutes, but I did it best of myself. So thank you very much for your attention once again.
Thank you very much, Professor. Thank you very much as well. And now I would like to invite the last speaker. It is Professor Robert Tomanek from University of Economics in Katowice. And you have 10 minutes as others. Please, it's your turn.
Good afternoon. I am Robert Tomanek. I represent the University of Economics in Katowice. My research team focus on sustainable mobility. In this project, we look at ESG in municipal services, including public transport. ESG, this is integrated conception, sustainable and responsible management, E, environment, S, social responsibility, and G, this is corporate governance. Okay. Yes. This is structure of my presentation. Next slide. Article thesis. The main message is simple. ESG is not only reporting. It is a management tool. ESG, at the same time, ESG can support modern management and help municipal companies build competitive advantage. This is a very strong thesis, but I think is true. Why municipal sector? The municipal sector, this is city logistic, this is energy consumption. Local government as owner can use ESG for supervision, comparison, and urban policy. Is possible and necessary. And this is why ESG in this sector is very practical, not abstract. Okay. Project start 1st January 2025. the potential of the public sector in the green transition. In this project, we have analysis of ESG regulations and reporting standards. Only European Union taxonomy, this is 600 pages of regulations. This is very, very large problem. CAVI survey, 300 enterprises from transport and logistic sector. FGE in municipal economy segments, heat, public transport and water, and pilot stakeholder maps in two enterprises from municipal sector, and carbon footprint calculations for public transport operators in GZM metropolis. Okay. ESG is in municipal sector. This is practice is present but fragmented. Municipal companies are improving energy efficiency, modernizing fleets and reducing emissions. But the problem is that these activities are often not connected. So the challenge is not to start ESG in municipal sector. The challenge is to organize it. And stakeholders, this is a strong problem. Stakeholders, key lessons is that research matters. Different stakeholders have different perspective and priorities. Good ESG starts with listening to stakeholders. Is very, very strong and important problem. And carbon footprint of public transport in GZM. For operators public transport in GZM metropolis, we identified direct and indirect emissions from different sources. And carbon footprint, not only calculation. This is instrument for reducing energy and costs. Reducing footprint is lower cost and more stable energy prices. This is responsible and sustainable. Okay. In this slide, we can see scope 1. This is direct emissions from fuel combustion. Scope 2, this is energy production emissions. And scope 3, this is emissions from value chain. For GZM metropolis and operators public transport from GZM. And this slide, 85% emissions is from energy use. Diesel fuel, electricity, and indirect emissions from production energy and transport fuel. This is well to tank or WTT. Energy emissions costs. And comparison public transport and cars. Public transport is lower emission in scope 1 and total emissions in public transport and cars. This is very important for public transport, lower emissions, lower costs. And reporting. In the European Union, reporting is very completing. But reporting under European standards, SRS, is difficult. Difficult for municipal companies. But European Commission recommends the voluntary standard reporting. This is VSME. In our opinion, VSME is a good solution for municipal companies. It is not only a reporting tool, it is also a tool for better management. The standard can lower the entry cost of ESG reporting, build a data culture, and prepare organizations for banks' expectations. VSME is very simple. In this year, my students prepared very good reports for 2 companies' public transport. Recommendations. ESG is a tool for increasing competitiveness and resilience. Carbon footprint reporting is the basis for energy efficiency, and VSME standard should be used to spread sustainable management in the municipal sector, including good ownership supervision practices. Okay. Thank you very much for your attention.
Thank you very much, Professor. So before I close the session, that I have a question to audience. Is somebody interested to comment, to put some question? We have time for that now. If not, so thank you very much for your participation. Thank you very much for 12 authors for preparing your presentations, for informing us about your activity. It was not easy to work with so great number of presentations, really 12 presentations, but very punctually we have finished, because we'd like also to give you some time before official dinner. So once more, thank you very much. We are closed.
One photo to prepare here. Yes.
Yes.
Would
you like to take picture with everybody?
Yes, everybody.
Okay. So please, if somebody is interested,